Today's lesson is on applications of exponential functions. So you have seen a couple of examples in the Survivor Lab, the M&M, the Rhino. So we have already been exposed to exponential growth and decay. There's a little bit more to it, so here we go. The two formulas that you see, A equals A sub 0 is the way you say that, times 1 plus r to the t. A sub 0 is often used to indicate your initial amount. And then capital A would just be your ending amount. R is your percent of increase or decrease in decimal form, and T is your time in years. So if you are multiplying something, if something's increasing, then it's already going to be worth 100% of its value, so you would do 1 plus the amount that you're increasing it by. If something's decreasing exponentially, then you would take the 100% of its value, current value, and you would subtract off that percent. So let's take a look. In 1970, the population of a city was 10,000 people. If the population has doubled every 10 years since that time, find the population of this city. So this formula could be A for amount. The initial population is 10,000. So A sub 0 would be 10,000. And it says that the population has doubled every 10 years. So the population is currently 100%, and 100% as a decimal is 1. And then it's going to double, so the R value is going to be also 100%. So you really have 200%. So you have 100% plus 100%, but that's really just as a decimal 1. So we have 1 plus the rate, and our rate was also 1. So it's going to double to the t. So it's A equals 10,000 times 2 to the t. So in 1980, that is going to just be 20,000. I mean, you can just see that it's going to double to 20,000. But if you use the formula, it would be A equals 10,000 times 2 to the first, because it's every 10 years. So every 10 years, you wouldn't go to the 10th, you'd go to the first, because you have one set of 10 years since 1970 to 1980. So then A is just equal to 20,000. In 1990, if the population has doubled every 10 years, it should be 40,000, right? Because it starts at 10,000, doubles to 20, doubles to 40. If we use the formula, it's going to be 10,000 times 2 to the second, because we have two 10-year periods. So that's 10,000 times 4. Now remember, you have to do exponents first, so you cannot multiply 10,000 times 2 first. And we get 40,000, which should make sense even if we don't have the formula. And then in the year 2000, if you doubled 40,000, you'd get 80,000. The answer is 80,000, but using the formula, the initial amount, and then 1 plus 1, or 2. Now 2000 would be 3 10-year periods since 1970. So that's 10,000 times 8, or 80,000, as we said. So write an equation to model this situation. We already did that. A is equal to 10,000 times 2 to the t. for C, if this exponential growth continues, what will be the population of the city in the year 2020? So now T is equal to 5. So 2020 would be 5 10-year periods from 1970. So A is equal to 10,000 times 2 to the 5th. So A is equal to 10,000 times 32. 2 to the 5th is 32. And that's 320,000. Okay. Now, we also have some things that deal with banking. If a bank compounds interest annually, which means once each year for annually, then the amount of money A in a bank account is determined by the formula. And the only thing that really got changed from the formula above was that now we have a P instead of an A sub 0 and an X instead of a T. So here in this formula, P is called the principal, same as the initial amount from above. Or it's basically the amount invested. R is the rate. So R is the rate. And X is the number of years. All right, so, and P is the principal, which is the same as that initial amount, okay? So, if we take $100 and it's invested at 6% interest compounded annually, so that means once each year. The amount A in the account is found by using the formula. A equals our principal amount, which is 100. And then we would have 1 plus our rate, so that'd be 1 plus, our rate needs to be as a decimal, so 0.06. 6% would be 0.06 to the T, or to the X. Okay, it doesn't matter if you want to use T, you can, or X, doesn't matter. So the formula is A equals 100 times 1.06 to the X. So find the amount of money in this account at the end of the first year. So if it's doing it annually, then X is 1. 2 years would be X is 2, 3 years is X is 3, and 4 years is X is 4. So it's just 100 times 1.06 to the first, which is 106. So that's how much you would have at the end of the first year. At the end of the second year, we would have 100 times 1.06 to the second, 112.36. The end of the third year, 100 times 1.06 to the third. So that's 119.1016. I'm just going to leave the full decimal. And then 100 times 1.06 to the fourth is going to be 126.247696. Okay, so let me just kind of go below here and show you something. Okay, so let me just kind of show you where this formula comes from. Okay, just watch. Okay, so if you took $100 and you multiplied it times 1.06, you get that 106. Okay, so if you took then that value 106 and you multiplied that times 1.06, so this first one should be year 1. The second one should be year 2. So let's see what's going on here. Okay, so 106 times 1.06 is, believe it or not, 112.36. So what happened here was you just are basically taking that 106, which is made up of 100 times 1.06, and you're multiplying that times 1.06. So you can see you're getting two of them, and that's why it was to the second power. And so, I mean, if you were to do this without the formula, so for the third year, so for year 3, we would take 112.36 times 1.06, and that would give you the 119.1016. But again, what's really going on here is you're taking that 112.36 was made up of, it was made up of 100 times 1.06 times 1.06 times 1.06, which was really 3 of them, 1.06 to the third. Okay, so that 112 was made up of 100 times 1.06. So this piece here makes up the 112, and that's that piece there. But altogether you have 3 of them, which is why it's to the third power. So that's how that formula gets actually developed. All right, let's go to the next page. Now, if interest is compounded more than once a year, the formula changes. So now you have a equals a sub 0. Could still be p, all right? You could still have p there instead of a sub 0. That's fine. And then you're not going to, if you're going to compound something, that means it's going to increase. So it's not going to be 1 minus n, it's just going to be 1 plus. And then the rate divided by n to the nt. Now, if you would like to see your teacher, they could develop that formula for you. It's a little bit involved, so you could see your teacher if you had questions about where that formula came from. Otherwise, you're just going to have to trust me for now. So now to the example. If 100 is invested at 6%, compounded monthly. So you need to think about monthly. How many times a year is monthly? Well, 12. Monthly would be 12. So the amount A in the account is found by using the formula. So we would go with A equals 100 times 1 plus 0.06 divided by 12. N would be 12 to the 12t. Okay? So that would be the formula. Now, we could simplify that. So I'm going to go to my calculator and do 1 plus 0.06 divided by 12. So 1 plus 0.06 divided by 12. It knows to do the division first. So we have 1 and 5/1000ths. So that's going to be 100 times 1.005, or 5/1000ths, tenths, hundredths, thousandths, to the 12t. So find the amount of money in the account at the end of 1 year. So we would go A equals 100 times 1.005 to the 12 times 1. So we would do A equals 100. Now you have to do this, you have to do this 1.05 to the 12 thing first. So that to the 12th. Okay, so we'd have to have that answer and then times 100. So it was, I believe, 1.06167. And then if we multiply that times 100, we get 106.167. Okay? If we do it for 2 years, we have A is equal to 100 times 1.005 to the 12 times 2. So that's going to be 100 times 1.005 to the 24th. So that's going to be 100 times, you have to do the 1.005 to the 24th first. So 1.127. And then that would be times 100, 112.7159. There's no mention of rounding, so I'm just putting the dot, dot, dot. And then for 3 years, it would be A equals 100 times 1.005 to the 12 times 3. Or A is 100 times 1.005 to the 36. And then calculate that 1.005 to the 36. So 1.1966, 1.1966. And then that's going to be 119.668. And then for 4 years, it would be A equals 100 times 1.005 to the 12 times 4. And this gives you 127.0489 dot, dot, dot. All right, number 4. Car that was purchased for $15,500 depreciates at a rate of 5% each year. So that means it's going to go down. So this is decay. So we're going to be using 1 minus the rate. 5% each year. So this is meaning that n is equal to 1. Find the value of the car after 8 years. So I have A equals initial amount, which is $15,500, 1 minus the rate. N is 1, so R divided by N would just be R divided by 1. So it's really just 1 minus 0.05 to the T. And they want to know after 8 years. So A is equal to 15,500 times 0.95 to the 8th. And again, we have to do the 0.95 to the 8th first. So 0.95 to the 8th. So we get 0.6634. And then when I just have that already in the calculator, so just times 15,500, and there's our answer, 10,283. 10,283 and 2 cents. All right, number 5, what is the value after 10 years of an investment of 800? This is the P. This is the R, which is 0.14 at 14% interest, compounded semi-annually. That's twice a year. So n is equal to 2. So you need to be looking for compounded, that word in there, to use the formula at the top here. So A is going to be equal to 800 times 1 plus, because it's an investment, 0.14 divided by 2 to the 2t, or 2x if you want. So A is equal to 800 times 1 plus 0.14 divided by 2 is 1.0116 repeating to the 2, and then we want 10 years. So 2 times 10, or, I'm sorry, yeah, compounded semi-annually, yep. All right, so then, oops, I think I have an error. 0.14 divided by 2, that amount is incorrect here. I originally had the problem as compounded monthly and changed it. So I got to go back in and find that. So 1 plus 0.14 divided by 2. So we get 1.07 to the 20th. So 3.869 times 800 is 3,095.75. 3,095.75. Okay, and that should make sense. Okay, 10 years, 14% is pretty decent amount. Would it be better if this investment was compounded monthly or compounded quarterly? Okay, so compounded monthly would be A equals 800 times 1 plus 0.14 divided by monthly would be N is 12. Quarterly would be N is 4. So divided by 12. Let's do 10 years. So 2 times 10 again. So now this one was the one I had. This is a 1.0116. Repeating to the 12 times 10, which would be 120. And then when I calculated 800, I need to do this 1.00. You need to do that first, but when it's all said and done, it's 3217.98. Versus if I do it quarterly, then A is 800 times 1 plus 0.14 divided by 4 to the 4 times 10. So that's 800 times, let me double check, 0.14 divided by 4. So 1 plus 0.14 divided by 4, 1.035. to the 40th. So we want to take that value to the 40th, 3.959. Then times 800, and we get 3167.41. So it looks like it would be better to compound more often. You'd make a little bit more, but not too much more. So it would be better to compound monthly. Okay, compounding continuously is another one, and this one involves that E, that irrational number. So if you're doing something continuously, this happens with these decays and some deer population. That's why there's so many deer. So you need a different formula. Okay, so the formula is A equals PERT P e to the RT. There's different variations, as you can see. So let's put one to work here. Okay, in the state park, the deer population was estimated to be 2,000. And increasing continuously. So you need to kind of look for those words at a rate of 4%. So 0.04 for the R. 2,000 would be the P. If this increase continues at this rate, and then 10 years, what would be expected for the deer population in 10 years would be the T. So A equals, or V equals P e to the RT would be 2,000 times e to the 0.04 times 10. So if you've got old operating system, you have to do 2,000 second divide, which is e, caret, and you might have to do parentheses, 0.04 times 10. I really didn't have to use the parentheses, but I did it to show you if you have an older operating system. So A or V, whatever you used, is 2983.649395. There was no mention of rounding, so I'm going to put the entire decimal. Next one, the decay constant of radium is negative 0.0004. So if it's decreasing, you're going to have a negative for your rate. So now there's your rate. How many grams will remain of a 50-gram sample? That's your P. Of radium, this is spelled wrong, after 20 years is your T. So I'll do V this time. So V equals 50 e to the negative 0.0004 times 20. And that's what you're calculating. So 50 second divide e to the negative 0.0004 times 20. Okay, so 49.60159574. Different kinds of problems. Okay, the population of Canada was about 24,100,000. Using one of the previous formulas, predict the population to the nearest tenth if the growth rate is 2%. So here's your rate. Here's your P. There's no mention of compounding. There's no mention of continuously. Year 2025. I have to do 2025 minus 1981, and I get 44 for T. So it's just a basic one. So A equals 24,100,000. The population is growing, so it's going to be 1 plus 0.02 to the 44. And if you work all that out, you have to do the exponent first with the parenthesis inside. You get 57,600,280.7. Next, the thickness of a sheet of paper is 0.004 inch. If X represents the number of times that this sheet of paper is folded in half over itself, what is the total thickness if it is folded over itself 15 times? Okay, so this is obviously the rate. Sheet of paper is folded in half over itself. So in half over itself, this is not the rate. This is how much, that's the thickness you're starting with, sorry. Your rate is 2 because it starts at 100% and then you're folding it on top of itself, so you're getting another 100%. So you're getting 200%, so it's equal to 2 for the rate. And then 15 is the year. So we end up with A equals 0.004 times 2 to the T. And that's 0.004 times 2 to the 15th. So your thickness of paper, if you tried to fold it 15 times, would be 131.072 inches. That should make sense. It would get pretty thick, and I had a hard time folding it over after the 6th time. Next one, almost done. In January, the population of a small town was 8,000. Each year, the population decreased continuously That should tell us we're using the PERT formula. Okay? If P represents the population, T years after January 1995. So find the population of the town in January 1998. So that means that T is going to be 3 because it's P represents the population T years after January 1995. So we have V equals 8,000 for P times E to our rate, and it's going to be decreasing. So I'm going to use negative 0.01 times 3. So we want to do that multiplication first and then e to that power next, and you should get 7763.56. So it should be decreasing. If you used positive 0.01, it would have been increasing. Part B, if this rate of decrease continues unchanged, what is the expected population in 2010? So now for 2010, T should be 15. 15 years since 1995. So V equals 8,000 e to the negative 0.01 times 15. And V is equal to 6,885.66. And I'm keeping the decimals because statistically they say that there's there's 2.5 children for every household. So that means between 2 and 3. So I'm keeping the decimal. All right, that's it.